Okay, this is a follow-up video to number 2 on the green worksheet for 4.3. And what we did previously was we saw that this little minus 2 makes the graph negative 4x shift right 2. And let's go ahead and look at that on our graphing calculator. So in y1, I want you to graph the line negative 4x. And in y2, I want you to put in negative 4 times the quantity x minus 2. I'll pause and come back when you have those in your calculator. Okay, we're back and we have both equations in y equals, one in y1, one in y2. We put y2 on bold so that we can see when we hit graph or zoom 6, there's the first line, there's the second line, and it appears to be shifted right 2. Okay, so it's a good way to check to see if you did it right. All right? Now, if you go back to the paper where I asked you to distribute, to simplify, all right, if you distribute the negative 4 to the x and to the minus 2, you get negative 4x plus 8. So what I want to ask you is, what's another way that you could have shifted the line negative 4x instead of right 2? How else could you have shifted it and have it be the same bold line that's on that other screen, on the calculator screen? So what other way could you have shifted it? Now it's negative 4x plus 8. Up 8. So let's test that theory out by going to y3 on the calculator and put in negative 4x plus 8. Now, if you just hit graph, you won't see anything because it's going to be covered up by the bold line. To see it, go back to the very beginning of the y equation, hit enter until you get the little dash 0. That's going to graph a little circle tracing where the line is going. So what you should see is it's going to appear in the same spot as the right 2. So right 2 up 8 would land you in the same place for this line. What would happen if you did that with the blue one? So the instructions on the page said, replace the x in the line 2x with x plus 4. And we did. And then it said, tack a little plus 3 on the end. So that graph would have gone left 4, up 3, and it would have made a picture. You could graph it now. Or you could graph a different function, and would it land in the same location? That's my question. Instead of making it move left 4, up 3, what does it come out to be when you distribute it and simplify? 2x plus 11. So what I want you to do is the same thing we just did for the red one. Graph 2x in y1, graph 2 times x plus 4, the quantity, plus 3 in y2, and graph 2x plus 11 in y3, and see what you notice. Okay, so here are the 3 equations. The 2x line, which was the original. The left 4 up 3 was the shifted one. The 2x plus 11 was a differently shifted one that would land in the same location. When you hit graph, I hope you see what I mean. There's the original, there's the shifted one, and there is the other line, which was up 11. Name a very important point that the original line goes through. The origin. What would that be? 0, 0? Okay. Where would that red dot move to if you moved it left 4, up 3? What would the new coordinates be? Instead of 0, 0, what would its new coordinates be? Negative 4, 3. Watch what happens when I trace y2, I want to hit down until I get to y2. I'm going to trace to -4 and hit enter. Is the point -4, 3 on that line? Yes. Okay. I'm going to go to the other line, which is y3, and trace it to -4. It's also at -4, 3. So you landed on the same line. What am I going to get on y3 when I trace to 0, enter? What's going to be the y coordinate? How far up did it move? 11. When you hit enter, it should say 0, 11. Now, I can't see it right now because it's just off the top of the screen.